Hi, we are from Section 1, Semester 2, Lab 1, 2024-2025. Mengucapkan Selamat Hari Raya. Bye-bye.
Kami dari Lab 1, Section 2, Sem 2 ingin mengucapkan Selamat Hari Raya Aidilfitri. Maaf zahir dan batin.
Hi, Assalamualaikum everyone. We are from Group 1 and we will be presenting about liquid extraction. So my name is Abdullah bin Majahar, my matric number 2314705. So basically I will briefly introduce about liquid extraction, which is this method is used to separate two immiscible liquid to purify it from a mixture. So as we know, this method is commonly used in petrochemicals, in pharmaceuticals, and many much that involve in separating organic compound from its mixture. So for the problem statement, as everyone knows, organic compounds don't purify itself in its pure form. So we need to extract it from a natural resource and we need to extract it from a mixtures, which is impurities. So these impurities we don't want, and we want the pure substance. So in these experiments, we want from a mixture of acid, naturals, and also base. We want a pure form of it in the extraction. So for the safety precaution before doing this method, we ensure that we have to use safety goggles and also gloves, and don't forget to use safety boots or shoes that have a closed surface. So because we handling with a very corrosive substance, which is HCl and sodium hydroxide. So for next steps, I will pass to Abrar.
So firstly, what we need to do is prepare the mixture. So we need to take 0.2 gram of solid of each acid, neutral and base using a spatula, and put it in the mixture flask. And after that, we need to add 10 ml of dichloromethane and put it in the mixture flask and swirl it until all the solid is dissolved. And after that, we put the mixture in the separatory funnel. So after that, what we need to do is we need to extract acid in the mixture. So we need what we need to use to extract the acid is we need to use a strong base to extract the acid, which is we use 10 ml of 5% sodium hydroxide and put the sodium hydroxide in the final separatory. And after that, we need to close the stopper and shake it vigorously so that the reaction will happen completely. And after that, we need to open the stopcock to release the pressure inside the separatory funnel, because the reaction will release a pressure. And close it the stopcock, and we put at the retort stand. And after that, we need to open the stopper to make sure that atmospheric pressure pushing down all the liquid that we need to extract. And after that, we can see in there's a 2 layer of liquid, which is at the upper. For the first case is acid, and at the bottom will be a mixture. So first we extract the mixture. We must make sure that our ice perpendicular with the funnel. So we separate it until bottom of the second layer, and you will get a mixture. And after that, we use a funnel flask, acid flask, and separate and put in here. But we know that impurities, this mixture still have a remaining acid, so we need to do the same step to get as much as possible acid that we can get from the mixture. So I will pass next to Aziz.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amirrul Aziz. My metric number is 2312179. And I'm going to present about the second part of it, which is how to separate between the base and the neutral. So as you know, after the first part, we separate the acid one, and then we still have the mixture. And in this flask, they still have the base part and also the neutral one. So how to separate this one? We need to add a strong acid, because base is basically react with acid. So we add 10 ml and 5% of acid hydrochloric, and make sure you need to use your glove, because acid hydrochloric is very corrosive. And then when you add, you need to transfer to this funnel, and then when you transfer, you put it. After that, you need to shake vigorously. It's just still the same as the first part. You need to shake, and then after that, you need to open the stopcock to release the pressure slowly, and they will produce a hissing sound. So after it stops, you can transfer to this funnel. When you transfer to this funnel, there is 2 layers after we shake. When they react, there will be 2 layers. The first one is the higher density layer, which is it's not actually base, it's actually the neutral part. So because the neutral part, the neutral liquid is more density than the base one. So we have the second layer, which is the base liquid. And after that, we take the first one is the mixture. You need to use the mixture flask, and then you need to extract it slowly, until the end of the first layer. And then after that, you can transfer, because the remaining is still only base, so you can transfer to the base flask, all of it. And then in this mixture, still have a very little base, so you need to do the same step 2 or 3 times to get a more accurate readings. So that's all, and then we can get the 3, because the remaining in this mixture is basically neutral one. It's only neutral. So we already get the 3 pure substance, which is acid, base, and neutral. After that, the experiment is actually complete for the liquid extraction. So basically, this process is commonly used for many chemical company that used to separate, for example, hydrocarbon. They separate pure hydrocarbon fraction from it to get pure high purity of carbon and also fuels, and also so many else hydrocarbon. So one of the company that use this is Petronas, because Petronas use many separation process, and one of this is actually liquid extraction. Okay, that's all from me. Thank you.
So that's the end. So that's the end of our presentation. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we are going to be presenting about the distillation process from experiment 1 and 2, that is extraction, purification of organic compound. Okay, so as we all know, we have 3 separation techniques. Can any of you tell me one of the separation techniques? Or you want me to choose one of you guys? Abdullah, you want to tell me something?
Liquid extraction.
Okay, good. Next example. Good boy. Okay. Now, so today we go 3 techniques that is included in the experiment is first extraction, that is separated by solubility, and then next is TLC, that is thin layer chromatography, that we have all did in this lab, right? So that is separated using bipolarity, and then right now we're gonna talking about distillation. So distillation is separated by boiling point. Okay, so the overall experiment, we want to separate base from the salt, hydrochloride salt form. So the problem statement for the distillation process is we want to separate the base compound from the dichloromethane solution, that is an organic solvent. So generally speaking, the process of this distillation is first we must have a mixture that have 2 compound. So and each compound we make sure that it have 2 different boiling point. Okay, so and then we must heat up the mixture with the temperature between the boiling point of each compound. So it must be lower than the higher boiling point compound, and then above the lower boiling point compound, so that we can collect the compound from the lower boiling point compound. Okay, so next.
Assalamualaikum. Assalamualaikum. My name is Muhammad Syabil bin Nasir. My metric number is 2313531. So I will explain to you about the apparatus of the distillation. So this is a distillation unit. We use this to separate liquid by their boiling point. So the apparatus that we see here, the first one is a round bottom flask. Round bottom flask is used to hold the impure water that we want to separate. And the next one is the distillation head. This distillation head will direct the vapor to the condenser, and also direct the vapor to touch the thermometer, so that we can determine the temperature of the vapor, so that we can keep the temperature under the boiling point of the other liquid that we don't want to vaporize. So the next apparatus is the thermometer. We use the thermometer to measure the temperature of the current solution, so that we can separate the solution. So before we set up the apparatus, we need to make sure that the thermometer are tightly sealed, so that no gap, so that no vapor will come out from the distillation head. And also we need to apply this clip to avoid any of the apparatus from falling off, or even worse, break. So the next apparatus is the condenser. The condenser have two have two holes. One is inlet and one is outlet. We use water in our condenser to reduce the temperature of the vapor that will flow from the round bottom flask to the condenser, and will condense the vapor into the receiving beaker. So the last apparatus is our receiving beaker. Receiving beaker will receive all the vapor that will condense to to liquid, and will be collected in the receiving beaker. In the end of our experiment, we will receive a pure substance of liquid that we want. Depends on the solution that we will heat up. So that's all for me.
Hi, my name is Muhammad Ishqal Aqeef bin Suhaimi, matric number 2328201. Okay, so I will explain about the procedure. After the liquid extraction, so we get the extraction in this flask. Before we heat it in the bottom flask, we need to add anhydrous sodium sulfate to remove the traces of water. Why we need to remove the traces of water? Because the water can interfere with our distillation. And after we add this anhydrous sodium sulfate, we let it dry, and then we pour it in the round bottom flask. And before we heat it, we need to add our granule to prevent it bumping and boil violently, and it will allow the solution to boil smoothly. Okay, after that, we heat it. And when we heat it, we need to let the water flow, and the water will flow from the bottom to the top, while the water will flow from the bottom to the top, because we need to achieve efficient cooling. Because how we need to achieve the efficient cooling? When the water flow, the gas will come from here. So let's say the coolest water meet the hottest vapor. So boom boom, cool. Okay, and then after the gas condense in the hollow section, it will condense into water, and then it will flow into our receiving flask. So the liquid with the lower boiling point will transform into vape and then condense into liquid. So for our final product, we get to separate our two different liquid. So that's for distillation procedure.
And Bismillahirrahmanirrahim. My name is Muhammad Usamah bin Ismail, and my matric number is 2313949. So I will explain about the precaution, the industrial application, and some examples. So the precaution that I want to mention is that using the sodium sulfate and anhydrous sodium sulfate is to remove excess water, to remove the traces of water. Why we use sodium sulfate anhydrous? Because the ability of the anhydrous sodium sulfate is because it can create bond to form salt with water. So for example, another compound, when we add water to it, it becomes solution. But for example, the sodium sulfate anhydrous, when we add water to it, it will become salt. The salt that will bond with water. So it will absorb all the water and remove, to make the compound more pure, to be less moisture and less watery. So that's the precaution that I want to mention. And the industrial application of distillation is, one of it is the petroleum fractioning columns. So what happened in the petroleum fractioning column is that the way we heat it the same way, because we want, in the petroleum is, we heat the crude oil. The crude oil is very mixturous and very viscous. So we need to heat it very at very high temperature and also at very low pressure. So we can use less at very low pressure, such as vacuum. We can use less heat to make the substance boil. So for example, when the crude oil is in the fractioning column, the crude oil will be fed from the bottom and will be heated by steam. So when we heat the crude oil, it will become, the mixture in the crude oil will extracted by its boiling point. So for example, at the bottom will be the hottest and will be the most viscous and the most high boiling point material will be at the bottom, and at the top of the fractioning column will have the least of boiling point and also very volatile at the top. So usually at the top is usually for gas for cooking. You know, the gas in when we cook it, when we cooking, we will use gas, right? So that's the example of the use of the gas at the top side of the fractioning column. And the bottom part is usually tar. Tar is when we use it to build road, tar road. So that's other industrial example. So the method we use for the crude oil extraction, also with the experimenting in the lab, is the we heat it, we distill it, we use boiling point as the measurement to separate each material. So I want to ask some of your audience to give one answer of other example of extraction mixture other than using boiling point as the measurement. Anyone? No. So one of the other filtration is gel filtration chromatography. So when we use gel filtration chromatography, we separate the material based on its molecular size. So for example, some material such as big metal, which we can find at in the periodic table, the bottom one usually the biggest metal, and the top one usually the smaller compound. So when we flow the liquid, flow the mixture into the gel filtration column, the bigger material, the bigger compound, the bigger molecule will flow the fastest, because the smaller molecule will be trapped inside the some like a net. The gel filtration is like a net. It will capture the small molecule, and the bigger one, the bigger molecule will not get trapped by the gel with the gel filtration. So it will let the bigger molecule passes, and the smaller molecule will come later. So that's the other example, and of other example of filtration. So this other example other than the distillation. So I think that's all from me. That's all from us, and thank you.
Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good evening everyone. We are from Group T and we will be presenting on experiment TLC. My name is Aina binti Jaafar with metric number 2314218. I will start with introduction and problem statement. So what is TLC? TLC or thin layer chromatography technique is a rapid, simple and cost-effective technique that used in organic chemistry. It helps to separate and identify a compound in a mixture by utilize the differences on how a substance interact with the mobile phase and stationary phase. So in this experiment, the stationary phase is the thin layer of silica gel on a TLC plate, and the mobile phase is the liquid solvent that move up the plate by capillary action. So you guys might wondering why is TLC is important, right? So TLC is very common in industry to check the purity of a sample, to identify unknown compound, and also to monitor the progress of a chemical reaction. So how does TLC work? TLC works by separates compound based on their polarity and also polarity and their interaction with the stationary phase. So the principle behind this TLC is the higher the polarity, it will interact more with the stationary phase. Therefore, it will slow down the movement of the compound up to the plate. Therefore, the high polarity compound will always on a lower level of the TLC plate, while less polarity compound will have a less interaction with the stationary phase. Therefore, it will move further up to the TLC plate or move faster through the system. So, the movement of each compound will be measured using the retention factor that will help us to identify and compare the substances. Next, the problem statement that we address is how can we identify unknown compound and check it and test its purityness using a simple and small scale laboratory technique. So inorganic processes, especially organic synthesis, knowing the purity of the compound and knowing the substances and the purity of a compound is very crucial. Therefore, TLC along with the melting point offer us is the one of the solution that offer us a quick and effective way to do this. So that's all. That's conclude my part. I'll pass to the next presenters.
Assalamualaikum and hi. So my name is Adilla Sofia. Let's continue to the next part of the experiment, which about the procedure and equipments required in this experiment. So firstly, let's go through the equipments that required. Firstly, we need the 3 beakers. We need 1 micropipette, 1 forceps, 2 conical flasks, 2 developing chamber, 2 TLC plates, rulers, pencil and ruler, and also 3 capillary tubes. Okay. Next, we prepare the TLC plates. Using a pencil and ruler, draw a horizontal line about 1 centimeter from the bottom of the plates. So this is a baseline. Another line is 1 centimeter from the top of the plate. So this is solvent friend. Okay. Also, along the baseline, label the spots for each sample, which are acid, base, and neutral. Also, don't forget to label the solvent. Don't forget to label the developing solvent that will be used. Alright. So, so now we prepare our sample solution in 3 separate beakers. Put acid, base, and neutral compound. Then we dissolve each of the compound in 5 ml of dichloromethane. Mix them well and set them aside for the spotting. Next, we prepare our developing solvent. 2 developing solvent. Okay, so the first developing solvent are in a ratio of 9:1, hexane and ethanol, and the second solvent is also in a ratio of 9:1, dichloromethane and hexane. So now we have both flasks in 10 ml of developing solvent. Place 5 ml of each developing solvent in the developing chamber using a micropipette. And don't forget to close the lid of the developing chamber to avoid it from evaporating. Okay, let's move on to the TLC plates. Okay, so using a capillary tubes, spot 1 drop of the each sample, which are again A acid, B for base, and N for the neutral, along the baseline, and make sure that the spots are small and apart from each other to avoid it from overlapping. Okay, and then we can put them into the developing chamber using a forceps. Using a forceps, gently place the TLC plates into the developing chamber. Okay, and then we let it to rise within 1 centimeter from the top of the plate. Once it's done, again gently take out the TLC plate, and then we can spot the drop, but we can see it through our naked eye. We need to use the UV light. Okay, assume this is a UV light. Okay, assume this is a UV light. Okay, we can visualize the spot and gently outline the spot that we see through the UV light. Okay, finally we can calculate our retardation factor. How to calculate it? Okay, so we measured it from the baseline to the center of the spot. This is B, and then measure it also from the baseline to the solvent front. This is A. By using the formula of RF equal to B over A, and we compute the value that we get into this formula, and then we can get the value of RF for each compound. So I think that's all from me. Now I will pass to the next presenter.
Assalamualaikum and hi, I am Amila Husna binti Shariena. I will be explain about health and safety precautions on TLC experiments. The first one is we need to make sure that we wear lab coats, closed shoes, and also wear gloves before starting the experiment. This is because we will be dealing with harmful chemical substances such as dichloromethane, which might irritate our skin and eyes. So by wearing lab coat and all, it can help prevent from any harmful chemical spillage onto our skin. Next is where the precaution of the TLC experiments is when we draw a line on the TLC plates, we need to make sure that we use pencils instead of pen. This is because pencils are made from graphite and it can insoluble inside the solvent, so it cannot interfere with the result. And then we also need to make sure that we don't touch the space between the solvent front and also the baseline, because our hands contain impurities that can also interfere with the result of the TLC. And then the next one is we need to deal with UV light for this experiment. And as we all know, UV light is very dangerous. So we need to make sure that we view the result from the we need to make sure that we view the UV light behind a transparent screen, so that we don't do any direct contact with the UV light because it can irritate our skin and also eyes. And lastly, we need to make sure that we dispose TLC plate and any chemical solution that we use inside the right containers, so that we don't, so that we can prevent from any lab contamination and also fire hazard. And that's all from me. I will pass to the next presenter.
Okay, hi, my name is Nurkhalisa binti Azizan, and I will present to you about application of thin layer of chromatography in industry. First is pharmaceutical industry. One of the main application of TLC in pharmaceutical industry is purity testing. Researcher must meet a strict purity standard before reaching the consumer. So TLC is to detect the impurity in drugs, even in small amounts, so that it can ensure the final product is safe and effective to use. Second is TLC is also used for monitoring reaction during drug synthesis. It allows to detect how far the progress has been made during the by observing the disappearance of reactant spots and appearance of product spots. Second is food industry. Application of TLC in food industry is to detect food colorants, additive, and preservative. TLC is to detect the food colorants, the dyes, and TLC is to detect the food dyes and preservative in final products, so that when we use too much dyes and preservative, it can be harmful to our health. And so TLC is help to detect whether it's too much or too less. So next is to analyze the contamination and residues, especially in pesticide. In agricultural products like fruits and vegetables, pesticide can remain on the outside and inside of the foods. So TLC can detect the pesticide. So TLC can detect the harmful chemical in food, so that it can prevent chemical exposure to consumer. Lastly is cosmetic industry. Application. One of the main application of the TLC in cosmetic industry is to identification and verification of raw materials. Cosmetic like lipstick, like this, has lots of ingredients such as plant extract and colorants and fragrances and active ingredients. So TLC helps to detect the right amount of the raw materials by comparing the chemical profile of the raw materials with the non-standard. So it can So it can help to prevent from consumer to. It can help to consumer prevent any too much active ingredients that which can cause skin damage or any type of allergies. So that's all from us.
Assalamualaikum everyone. Today our group 4 we will present the recrystallization process. For first of all, recrystallization is the process, is the technique for us to purify the solid compound, and this process is widely used in the industrial and lab process because it will help us to get the impurities purity from the impurities better. So the key principle of this technique is it will be decide on the compound solubility, and the compound solubility will increase along with the temperature. So means that the solid compound will be dissolved in the hot solvent. Generally, this process is we have to choose the solvent which is highly soluble in high temperature and purely soluble in low temperature, which is water. And during the experiment, we dissolve the compound with hot solvent, and then we cool it. We cool it slowly in the room temperature, and we divide it into 2 flasks. Well, the first flask we cool it in the room temperature, and the second flask we cool it in the ice bath to encourage it to form the crystal. Next is the precaution. The key precaution during the process is we have to choose the right solvent and use the minimum solvent to purify it without losing any product during process. And next is we have to let it cool under room temperature, so the crystal the formation of crystal will get better. And next is the problem statement. To purify the compound in lab and industrial process, which normally the compound is impurities. So during the process, we have to choose, as I mentioned before, we have to choose the right yield of solvent. And next is we have to use the the minimum solvent for the compound to dissolve without losing any product. So because if we don't keep taking mind about those things, later on it will affect our performance and our safety and our result, etc. And yes, that's all. So next we hand to Umairah.
Okay, now I'm going. Okay, now I'm going to explain about the equipment and method for recrystallization of the acid. First, the equipment that we need is 2 conical flasks, 1 beaker that contain ice, filtration funnel, vacuum pump, filter paper, and the last one heating plate. So let's move on to the method part. First, you need to add half of dry acid precipitate in these two conical flasks. One conical flask represent as the single solvent flask and another one represent as mixed solvent flask. First, you need to add 5 ml of hexane into single solvent flask and 5 ml of methanol or water into this mixture solvent flask. Put these two conical flasks on this heating plate and wait until they boil and let them cool at room temperature. For the mixture solvent flask, you need to immerse it in ice water bath. Just imagine in this beaker we have ice and you need to pour this solution into this filtration funnel. But make sure the switch of this pump is on and you have to put this filter paper in this filtration funnel, but you need to cut into this size. So you will see the crystal will occur on this filter paper, but you will see the crystal occur on this filter paper, but you will see the difference between these two solvent. Because what can I say, the rate of crystallization is depend on the rate of cooling. Cooling is very fast. The atom doesn't have time to rearrange themselves. But for crystal that cool slow, they have time to rearrange themselves. So it will look different between that. So next.
Okay.
Oh.
Okay. Okay, I will explain about application of crystallization in industry. In industry, crystallization is very need to scale for using a scale up for make sure that the industry is using a huge substance. So the first one, industry use in recrystallization use in pharmaceutical industry, which is paracetamol, or other name is acetaminophen. It is very need to make sure that the recrystallization because it is remove the impurities, which is we need to ensure that the high purity to the product that we need. The second one is bulk chemical manufacturing. Bulk chemical manufacturing used to dyes, pigments, food additive, and also agrochemicals. For example, it is using a product that need to make sure that the recrystallization need to use which is dyes industry, which is azo dyes. Azo dyes, it is make sure that the recrystallization using that to ensure that the no amounts of impurities in the crystal, which make it the product is purely a dyes for example for color, it is have a consistent color, which make if we don't have consistent color, it will affect the color of the dyes. So we need the recrystallization which remove the impurities in the system. So the third one is fine chemicals and specialty materials, which for example is silicon compounds in semiconductor. For example, silicon compound, it is use a thin film chromatography to make sure that the electronic is in a good, it's a pure silicon. So it will not, so the recrystallization make sure that the no amount of impurities in that silicon compound. So the recrystallization is very essential for industry, especially in pharmaceutical chemicals and electronics. It also a backbone technique to ensure that the chemical industry is using a modern chemical industry. That's all for me.
So, Assalamualaikum everyone. I will explain about the safety, health and precaution of this experiment. So, first thing first, we need to follow the general precautions. We need to wear a lab coat when we handle this experiment because there might be a chemical spills, and also need to wear a glove to avoid from the direct contact of the chemical and solvents. So the next one is ventilation. So we need to handle this experiment in the fume hood, well ventilation fume hood. It is because some of the methanol and hexane might be release harmful vapor which will affect our breath, and also fume hood will minimize the release of the vapor. So the next one is vacuum filtration. We need to handle this vacuum filtration apparatus carefully. It is because when we not suck the vacuum pump properly to the flux, the flux might be shattering and injury the other person. So we might make sure that it is well secure, and also we need to make sure that the vacuum pump is well functioning, because there might be some of the solvents and also the crystal get into or suck into the vacuum pump, so the pump will not be used anymore. Next, we need to ensure that the hot when we handle the hot plate, we do not touch the hot plate when it is currently being used, because we might hurt ourselves. And last, the crystal and also the solvents that we have used, we need to dispose in the correctly disposal waste, because if not, if we just throw in the sink, we might making the release of the vapor into the surrounding. So, have anything? So that's the end of our presentation. Thank you.
Okay, Assalamualaikum and good evening everyone. Okay, our group will present about liquid extraction. So my name is Aina binti Muhammad Yasin.
My name is Alida Suraya. My name is Alisa Nadira.
So I will start the discussion. I will start with the introduction and the problem statement of liquid extraction. Okay, first of all, what is the liquid extraction? Basically, it is a technique that we use to separate compounds. Basically, it is a technique that we use to separate compound based on its solubility in two different liquids. Basically, we always use organic solvent and also we use water. Okay, so when we mix these two liquids together, some compounds prefer water layer and some compounds prefer organic layer. And then when we use this technique, we can separate compounds and also purify compounds into a mixture. And then for this experiment, the organic solvent we use is dichloromethane, and for the aqueous solution we use water based. So the important thing that we need to remember is dichloromethane is more denser than water. So the chromatin will be bottom of the layer and the water will be on the top of the layer. So to make more understanding, let's imagine oil and water. If we mix oil and water together, what we see, you see, you will see two different layers, right? So it is clearly seen that some substance prefer oil layer and some substance prefer the water layer. Okay, so why we need to do this? Let's move on to the problem statement. Okay, in real chemical reaction and also natural extraction, we use the final product. We always mess it up because it contains of 4 components. The first component is acid, bases, natural compounds, and also unwanted impurities. So when we doesn't do the separation process properly, we always get difficult to do the separate process and then have need a lot of time. Okay, so without using LLE, the process will be the compounds will mix up and then it will hard to separate. That's all from my part. Now I would like to pass to the next presenter, Alisa.
Alright, thank you. So I will be explaining about the procedure as well as the health and safety precautions. So the first one is the most obvious one. Make sure to wear a lab coat and wear gloves to avoid any skin contact, because for this procedure we will be dealing with 3 compounds and reagents, which is acid, base and neutral. So the first thing is we will be using a spatula to take to weigh the acid, base and neutral compounds separately before mixing it all into one flask. So this flask is the mixing flask, which has all 3 compounds inside it. And make sure to label every single flask to avoid any confusion and avoid any mixing. So after we've added all the compounds, we need to dissolve it with DCM. So we'll be dissolving it with 10 milliliters of DCM, and make sure everything has been dissolved. We just want all liquids. Alright, so once everything has been dissolved, we will move on to the first extraction, which is the acid extraction. So the mixture will be put inside this stopper funnel. Make sure that the stopper funnel is fully closed to prevent any drippings. So this will go into the stopper funnel, and to this we will add 10 milliliters of 5% sodium hydroxide. Once that is also poured and inserted, we will have to shake this vigorously, and after shaking, make sure to release the pressure within it so that it won't explode. And make sure that when you release the pressure, the tip is facing away from your teammates. Alright, so now that everything has been mixed, this is going back on the retorter, and we have to wait until there are visible layers. So instead of a single liquid, this is what we're this is what we will be waiting for. Sorry. Sorry. So down here will be the mixture. The liquid will separate into two parts. The lower part is the mixture, whereas the upper part is the acid, which is what we want to extract. So once the layers are visible, grab the acid flask and turn on the stopper so that it will drip down. And once all the acid has been collected, the remaining liquid will be inserted back into the mixture flask. To get optimal results, pour the acid mix. To get optimal results, we need to pour the acid mixture back inside and then add some more of the sodium hydroxide. So basically just repeat the steps until you're satisfied so that you can get pure acid. All right, now moving on, we'll be doing the base extraction. To prevent contamination, we'll be using a new stopper funnel. So just like the acid extraction just now, we take the mixture, which now only contains base and neutral compounds. The acid has already been separated, so we just pour this in, and then we add the 10 milliliters of 5% add 10 milliliters of 5% hydrochloric acid. And then just like before, we shake it vigorously and release the pressure. So what we're left with is two layers of so what we're left with later is no longer a mixture. It's no longer a mixture, but instead a neutral. The bottom layer is the neutral, whereas the upper layer is the base. So grab the neutral flask because the neutral layer is at the bottom, so this will be removed. This will be removed first. This will be removed first until only the base layer is left. And again, to achieve optimal results, we just repeat the experiment by adding more of the hydrochloric acid and remove the neutral compound. And with that, you have a pure base. And with that, you have a purely base compound as well. All right, so I believe that's all from me. I will move on to our final presenter.
Okay, now I will present the last part, which is the principle and the application in the industries. So for the liquid extraction principle, it is widely applied in industries such as petroleum, chemical, pharmaceutical, and food industry. So for the principle, basically, we all know that in the lab, we use like separatory flasks, and the most important part is we have to use the chemical solvent or organic solvent, such as dichloromethanes. So for the first example is in petroleum industries. So in petroleum industries, they have like extraction towers. So the extraction towers are being used to separate the aromatic compounds such as phenol and aniline from the wastewater or the crude mixture. So the concept or the principle that being used in the tower is same as we use in the lab, that we use immiscible solvent such as water and organic solvent to produce something later based on the different solubility. That's why at the end in the petroleum industry we're going to have like different products such as diesel, RON97 and RON195. So moving on to the next example is in pharmaceutical industries. So specifically for the production of antibiotics such as penicillin. So in the production of penicillin, we're going to start with the broth or fermentation. So this fermentation broth is contain high antibiotic. It's going to be mixed with the organic solvent. So it will later appear when we will see that the penicillin is more soluble than the inorganic layer. So the latter, how do we get the pure penicillin? How do we get the antibiotic? So later, the mixture will be evaporate. So we will be left with the pure penicillin, which is our antibiotic. So that's how we get our pure antibiotic, which is penicillin. So in the last example is in the decaffeination of coffee beans. We all know that usually we will drink the caffeinated coffee bean. Basically, everyone know that coffee has caffeine, but not everyone can drink coffee because basically caffeine can give you like anxiety, you know, you will be nervous or something. So that's why they produce the decaffeinated coffee bean. So how do they produce the decaffeinated coffee bean? They will use the dichloromethane as our organic solvent. So the coffee beans will be soaked. Later, the caffeine will be dissolved in the solvent. Basically, dichloromethane is immiscible with water, but it can dissolve the caffeine effectively. That's why we choose dichloromethane as the organic solvent. So later, the caffeine will be dissolved and diffused in the water and then extracted into the organic solvent. So that's how we can get the decaffeinated coffee bean without the caffeine. So we can still have the coffee bean without the caffeine. So that's how we can get the decaffeinated coffee bean. I think that's all from me and from my group. Do you have any question or do you guys understand? Yes. Okay, that's all from us. Thank you.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening to everyone. So we from the group 2, we want to present about the distillation process. So my name is Hakim.
My name is Majahar.
My name is Muhammad Aziz Daniel Besaifunizam.
My name is Hadif Hafizi.
So distillation process is a type of separation process. Is one type of the separation process that separates the mixture that have the same property, chemical property, to extract the liquid in form of the vapor, and then we collect at the collect station. Okay. So so I want to ask you guys a question. How many type we have of distillation process? Is it 1, is it 2, is it 3? Just a guess. 2. You said 2. 4. 3. Okay, the answer is?
Yes, the distillation have 3 different types. Okay, 3 different types of distillation. Distillation has 3 types, which is first is simple distillation. Simple distillation we like we use in the lab, and like this is a simple distillation, and we usually the distillation in simple distillation usually the different boiling point is below 25 degrees Celsius. Okay, this for simple distillation. For the second one, fractional distillation. Fractional distillation Usually, we will see at the large scale of industry, like we make a petrol or diesel, we say to refining the crude oil. The figure like for distillation of fractional is like this. Where this had a heat and has a fractional part to distill. Okay, the third one is vacuum distillation. Vacuum distillation usually for the material, for the compound has a very high boiling temperature, usually above 150 Celsius. Like I give some example like glycerol. Glycerol has boiling point almost 290 degrees Celsius. That we use to vacuum distillation to make the to avoid to make the low pressure for the glycerol. Okay, for the next part.
Okay, so next, we know that there is a different type of distillation, right? Now we need to also know why distillation is very important. We know that distillation is a type of separation technique that we use in industries. So it is crucial because in industry, many like mixture solution that needs to be separated. So if we use want to separate like liquid for simple distillation or use fractional distillation. What I'm talking about. Distillation play a very crucial role for separation technique in every sector, such as for the crude oil or water and other example.
Now we know that the meaning of distillation. We know that distillation is technique to separate liquid mixture based on their boiling point, and we know that the type of distillation has simple, fraction, and vacuum. So we can make a problem statement. That is, distillation can be used to separate liquid mixture. Second, we can use to purify solvent in mixture, and lastly, we can isolate valuable component in mixture. For example, we want to extract alcohol from fermented liquid.
Okay. So that's all for the introduction part. Okay. Then while we doing the experiment, so we must an extra precaution step must be taken into the account. The apparatus like boiling stones, Bunsen burner that has some energy, that is heat, we must carefully handle it. So what the precaution step is, always wear a glove so that there is no direct contact between the skin and the heat, and there is no injury lah. And then make sure that the apparatus is not damaged by as the person that doing the experiment.
For the second part, for precaution and safety in lab in this experiment is to preventing the glassware accident. In this experiment, we use a lot of apparatus glassware like condenser, round bottle, flask, and tunnel flask and beaker, and we make sure we always to use this glassware carefully when to set up install the apparatus. We must set up with slowly and steady, and also emphasize for checking the crack in the glassware and make sure no cracks before doing the experiments. Okay, for next.
So next part in precaution that we need to take account is we know that dealing with distillation, we may also deal with some volatile solution, right? What is volatile solution means? Do you guys know what it means? Don't know. Okay. So the meaning of volatile is like the solution. The solution will condense faster to air. So the precaution is we always need to wear the mask when we dealing with the volatile solution so that we don't inhale the vapor. So it will secure our lung for our lifetime. And also, we also, when dealing with solution that are volatile or corrosive, we need to wear glove, and also we wear goggle eye to prevent the substance to touch with our hands or eyes. And also in industry, we need to wear a full PPE, which is personality protective equipment. Okay.
And for the last precaution, I will tell about ventilation and emergency preparedness. So when we do a laboratory experiment, we must make sure that when we do the experiment, it has well ventilated area. Why we must have to be in ventilated area? Do you know why? Because when we boiling, there will be gases. When the gas, we did not want to inhale the harmful gases. So we must make sure that when we make any laboratory experiment, we must make sure it well ventilated. And then about emergency preparedness. So what we must know in emergency preparedness, we must know the location of fire extinguisher. That is fire extinguisher. And then we must know the more important thing, the safety shower and eye washer station. So if we have do mistake in emergency situation, we can just act fastly to the emergency station.
Okay, that's all for the precaution step, precaution part. Robo. Then we move to the principle. Okay, one of the principle that we use in the distillation process is PB, and boiling point is BP, and vapor pressure. So what's related the boiling point and vapor pressure is when the mixture that contains various element that have a different boiling point. Boiling point, vapor pressure is play a role in this process. So when the low volatile mixture is heat up, and then the low volume, the low volatile mixture is vaporized first. And the more volatile component is remain in the liquid form. And then so that is related when the for example glycerol that ethanol that have 70 degrees Celsius, which is its boiling point, and water which has 100 degrees Celsius. Which one is the more volatile? That will go up first. Is it the higher boiling point temperature or lower boiling point temperature? The answer is lower, because when the boiling point is lower, vapor pressure is high. Vapor pressure is when the mixture is heat, the heat converts the energy into the mixture, and the molecule inside the mixture is gain a kinetic energy to move upward. So that's when it is have a vapor pressure that is higher, then this is when they will vaporize first, and this is remain.
Next process. What you guys think the next process? No. Okay, the next process is condensation process. Okay, condensation process is it occur in this condenser where is the vapor will change into the liquid in the condenser. How the condenser rolling this phase change is when the condenser is remove the latent heat from the vapor, and as is the heat loss, the vapor change into the liquid and without a changing temperature. So that's from the for the condensation process. Next.
Okay, in the same scope of principle, there also we need to talk about back to the simple distillation and also fractional distillation. So as we can see in front of you guys, we have the simple distillation equipment. So in the simple distillation equipment, there is a drying agent which is we use sodium sulfate anhydrous, which is drying agent act to absorb water in the solution. So we can get the pure solution. And also in our laboratory, we have the anti-bumping granules. Okay, what is the function anti-bumping granules? Is to prevent when the boiling process occurs, to prevent the solution to bumping. Okay, next for fractional distillation, we know that each of solution have a different boiling point. So in fractional distillation, for example, at the top is butane, so each of these component, which is butane, kerosene, and diesel, each of them has a different boiling point. So when the heating occurs, the lowest boiling point will condense first. So the condensed solution will go out at the top, while the highest boiling point will go out at the lower of the fractional distillation. Okay.
Okay, and for the last, for principle, I will tell you about important phase changes in distillation. As we can see, they already tell us about the phase changes, so I will highlight it. So, the first important phase changes occur when boiling point. So, when boiling point, the liquid will change into the gas, the vapor. So, what we call the phase is evaporation. And then the vapor will flow into condenser. So, the phase changes will condense vapor to liquid. What we call it distillate. That's all happen in this distillation.
Okay, then we go to the application part. Like you guys see in the front, that is simple, vacuum, and fractional. So I want to focus on the fractional, which is usually used by the industry, petroleum industry, that refine the petroleum to get a various product like butane, kerosene, and diesel. The easiest example is that the RON 95, RON 97, and diesel. That is the common product that petroleum industry produce. So butane, because this is crude oil that come from the underground, under the seabed of the ocean. So that's this crude oil contain many element, and because this element has and molecule has very different boiling points. So like butane is vaporized first, kerosene vaporized lower than butane, and so on. This is the lowest boiling point that will vaporize. This is highest boiling point.
Okay. Another example is in the alcohol production, which for example, in the example is alcohol production. We use distillation to separate the ethanol from the fermented mixture. In conclusion, one of the most of the fundamental separation technique is distillation across to our daily life, meditation, and science to make it an essential in modern society. Okay, that's all from us. Thank you very much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim bin Hussein.
My name is Muhammad Haika bin Ridwan.
And my name is Muhammad Nabi Hakim bin Yahya.
So we are from Group 3. We're gonna present experiments about TLC. So first of all, let me start first with introduction. So first of all, what is TLC? TLC is basically stand for thin layer chromatography. It is a rapid separations and qualitative analysis of a small amount of material. So TLC, I like to separate the word with TL and C. TL stands for thin layer, which is a thin coating of stationary phase, usually silica gel or aluminium. So next is chromatography, which is the C1 from TLC. Chromatography is generally mean a separation process. It comes from Greek word, which means color writing. Chromatography is separation process based on the movement through stationary phase by the influence of the solvent. So when the solvents move up the plate here by capillary movement,
the different compound in the sample will resulting different compounds in the sample with different rates will resulting in separation. So that's all that you guys need to know about TLC for introduction. Next, for problem statements, as we know in chemical and pharmaceutical industry, it is very important for us to identifying the compound that in our mixture that we want to create our product and others. It is very important to keep track our quality, and for some time it's for research purposes. So there is a lot of methods that we can use to solve this problem. However, some of the problems it is not very efficient. It is very high cost. It is very expensive. It is very time consuming. So here TLC that we can use it, use the experiments to identifying all of our needed. It is very cheap. It is very straightforward experiments, and it is easy to do. So next, I move to the methodology or processes that we're gonna do to run this experiment. So first of all, for this, we can gather all of our equipment here. Like you can see, we gather it all at one places. First, we will have 3 beaker that we're gonna label it. First, for acid. Second, for base. And the second one for neutral. We can label it as A, B, N. So first of all, we're gonna take a small amount of acid, base, and neutral and put it inside this beaker. So next one, we take 5 ml of DCM using micropipette. We suck it and put it inside each of the beaker. So done for the beaker part. So next one, we need to prepare for the solution that we're gonna put into this what is it? Developing chamber. So we're using this flask. So we gonna mix solution into each of these flasks. First flask, we're gonna have hexane and DCM, hexane and ethanol. Next one, we're gonna have ethanol and hexane. So how much the amount that we need to put inside this flask? We need to put the ratio with 9:1, 9 ml and 1 ml with total of 10 ml. So we put inside this and we mix it very well, and then we take 5 ml of each of this mixture to the developing chamber. Okay, done for the developing chamber part. So next, we prepare for the TLC plate. For TLC plate, here TLC plate, we have 2 pieces. 2 pieces. We need to label it. We need to put a straight line, 1 centimeter from the bottom and 1 centimeter from the top for measurement purposes. Next, we also label the spot that we need to spot the acid, base, and neutral on the line. If you can see, we label it as A, B, N. So next, if done, next we take this capillary tube. We take the capillary tube for spotting at the TLC plate. We used a capillary tube because we need very little amount acid, base, and neutral to spot on this plate. We take it little bit only and we spot it for acid. Next, we use another capillary tube for base and another capillary tube for neutral. Then done. Next, we put it inside this developing chamber. Each of this one, this also we use it. We put it and we let the solvent rise. Then we let for about 1 minute. Then we take it out and let it dry. So after it dry, we can use it. We can use spectrometer to read the data and take it. Okay, done.
Okay. So now I will highlight some key safety precaution and health concern while working in this TLC. Okay, first is general safety measurement. Like we need to wear PPE, like lab coat, mask. Mostly in TLC, we will handle this chemical. This chemical is high volatile solvent. So it mostly it is easily evaporated to the surrounding. So we need to wear mask and glove to protect from skin contact. And when I talk about the high volatile solvent, we need to work in fume hood at behind that. So we need to do this TLC experiment to prevent inhalation, to prevent we inhale this high volatile solvent. Okay. When we preparing the solvent, the sample solvent and developing chamber solvent, especially for this TLC developing chamber, after we put the developing solvent in this chamber, we must close the lid after we put it to prevent the evaporation. Then for the TLC plate, that I want to talk about for you because we should protect the surface. We don't want to make a contaminated TLC plate. And for spotting, we need to use clean and different capillary tube to prevent cross contamination also. When we are done with this process, after this we go to the UV light process, right? So in UV light process, we need to ensure that we limit the time exposure. Is that for precaution? But when for health causes, this is the most hazardous solvent that we using in this experiment. Because of what? DCM is a suspected carcinogen that we can increase the cancer risks that causes dizzy and nausea. While hexane is the second level of the hazardous, is the same with ethanol, highly flammable. But hexane, it can give some nerve damage. For ethanol, it's the least hazardous, but it can give some irritation. For UV light, it depends on wavelength. You have two wavelengths that we use the previous experiment, like short wave and long wave. For short wave, it's most hazardous as also because we are already used some hazardous things. That short wave mostly we need we should prevent use short wave constantly. Because we don't want to get some like skin contact that can increase the cancer risk also. And if we may contact the UV light, our eyes can burn, like corneal burn. But the long wave, even though it's safer than short wave, it can give some risk. But it may cause some irritation and retinal burns also. Now I will pass to my friend.
Okay, we move to the interesting part, which is, who know?
Industrial.
Yes, smart. Industrial part. Okay, for the industrial part, why we use TLC in the industrial part? First, I will give 3 examples for the industrial part: pharmaceutical industry, food industry, and cosmetic industry. Okay. For the pharmaceutical industry, we use TLC for to testing the purity of the substance. For example, scientists use TLC to test the impurity of raw material and the final product. For example, in the production of painkiller, which is the medicine. In the production of painkiller, we use TLC to check whether there are leftover reactant or byproduct that occurs during the production. Okay, and then for the next one, we use TLC also for monitoring the reaction. For example, the scientists use the TLC to monitor the reaction if it's complete or not, so that they can save more time and use the right amount of ingredient needed for the production. Okay, we move to the second part, which is food industry. For food industry, we use TLC to check whether there are any additive, contaminant or toxin in the product. Okay. For the first example, we use TLC for to check whether there are any harmful substance, such as azelaic acid, which is produced by the mold in nuts or grains. And then for the second example, we use TLC also to check any additive coloring for spices. Do you guys know in Sudan, the country, they use this additive coloring in their chili powder? Don't know, right? I tell you right now. Okay, this additive coloring, they use red dye coloring for the chili powder to make the color more vibrant, so that the customer will buy it. But this additive coloring is actually harmful to human when they are consuming it. We move to the last one, which is cosmetic, right? Cosmetic production. For this industry, cosmetic industry, we use TLC to check whether they use active ingredient such as salicylic acid, or salicylic acid, which is, who can guess, in what?
Corrosion.
No, in acne cream or UV light. UV light in sunscreen, correct. And they use this with the right amount of concentration. If they use the concentration higher, it can cause harm to the skin. And then we move to the advantages of this in the industry. For advantages, the first one is why we use TLC in the industry, because it is cheap. It requires minimal equipment and ingredient to do the TLC. And then the next one is fast, because we can achieve the result of TLC within minutes to hours. And the final one, why we use TLC, is easy to use, because normal people, like the normal technician, also can use this TLC method without any advanced training needed. Okay, that's it. Any don't understand? No.
Understand already.
All understand, eh? Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatimah Zahra binti Zaudin. So today my groups will present about recrystallization. Okay, so this is Safwat Arshad and this is Natasha Yuni Az-Zahra. Okay, first and foremost, I will explain to you guys about recrystallization. Okay, recrystallization is a purification process used to remove impurities from solid compound by dissolving in a suitable solvent. For example, do you guys know example for the solvent, suitable solvent? No? Alida don't know? Okay, we can use methanol, okay, at high temperature, and then we cool it slowly to make sure the compound can crystallize out. Okay, why it is matter? Because some of synthesis compound are not completely pure, so the recrystallization helps to isolate the compound to make sure it is in the pure substance. Okay, so now we are moving to the problem statement. In this experiment, there is 3 problem statement. The first one is solvent selection. The second one is cooling process, and the last one is product loss. Okay. Okay. The first and foremost, it is very important to us to choose the suitable solvent. For example, methanol. It is because an ideal solvent can dissolve a large amount of compound when it is hot, but when it is cool, it will only produce a small amount of compound. Okay, we have to choose the suitable solvent to make sure that the product we produce larger and purer crystal. Okay, the next one is cooling process. Cooling process is very important because we have to handle it carefully, and we have to handle using low temperature, because the more slow the temperature, the more crystal we produce, and more larger crystal we produce. And the last one is product loss. Product loss, when we are purify the compounds, not all the compound we will get. This means when we are filtering or the crystal might be stick on the paper filter, or it can make the crystal reduce.
Okay, Assalamualaikum warahmatullahi wabarakatuh. How are you guys today? Today I will run the experiment here. So as you can see here, we have vacuum, we have conical flask, we have beaker, we have heating plate. And first of all, we have here acid flask, the single flask, and the mixture flask. So what we have to do first, the vacuum here, it will dry out the solution, and then the solid form will form up here, and then we can have something like this. And then we can put it in the conical flask, in the mixture, and then when we run the another experiment, we can put it in the single flask, like this. And then we need to add 4 mixture flasks. Wrong flask, sorry. So for the mixture flask, we have to add 2 things, which is water and methanol. Make sure you use the dropper to put the methanol, Do you guys remember the cylinder? The cylinder measure. Do you remember? Yes, that's good. Make sure you use this to put it in the cylinder first, and then you can put it in the mixture flask. And then for water, use the distilled water that we have there, and then put it in the cylinder graduate, and then you can put it in the mixture flask. Then after that, for single flask, we need to put 5 milliliter of hexane. After we done put that two solution in these two flasks, and then we need to put it on the heating plate, and then turn on the heating plate and let it boil. And then after it boils, just turn off the heating plate and take it off from the heating plate, put it aside, let it cool first, let it cool at room temperature first, and then for the mixture flask, we have here, just imagine, in this beaker we have ice bath, and then we make a room, and then maybe we can put it inside and let it cool inside there. For the single flask here, just put it aside and let it cool to room temperature. And then after sometimes we can see the crystal starting to form inside or below the conical flask. Then after we take this out, and then we compare them both here, we can see the crystal has started to form below the conical flask. Can you guys tell me which crystal is more beautifully created, the single one or the mixture one? Single. Yes, that's right. Because we left the single flask on room temperature, but for mixture, we put it in the ice bath, and it happens not naturally, and then because of the sudden drop in the temperature. And then we can see if we compare them both, the single flask is more beautifully formed. Is that it? No. We have health, safety, and precaution. So the first thing first, always wear your gloves. Wear your gloves here and your lab coat. And avoid touching the hot plate because it will burn your hand. And when you scrap the leftover here, please be reminded not to put too much, because the crystal is late to form. It will take some time, and if you put too much, it will take a longer time, and maybe it won't crystallize at all. So it won't form anything on the below of the conical flask. And then make sure you don't use a dropper for the same solution that I said just now, for the methanol, for the hexane, for the water, because you don't want any hexane in the mixture flask, you don't want any methanol in the single flask. And make sure there is no direct contact with any solution, any solid form of the mixture, or any solid form of the single acid that we form. Make sure you use spatula for that, and use different spatula for mixture, different spatula for single. And I think that's all.
Okay. For my part, I'll be discussing about the principles of the principle of these experiments that apply to the industry, which is recrystallization. Do you know what the last product that our friend just now present? What is the last product that we get from? Okay, good. Okay, crystal. So basically the principle, the principle is same. The principle is same that used in several types of industry. First of all is pharmaceutical industry. Pharmaceutical industry is really relies on this process because it want to produce drugs that is really pure, completely pure. Because when there is even a small contamination that have in the drugs will very dangerous. So it want to completely pure. Okay. For example, common example is do you know what when we have headache, what medicine we take? What? No. No. Yeah, no, painkiller. Aspirin, that's good. Okay, aspirin undergo recrystallization to get to purify acetylsalicylic acid. So the acetic and remove the impurities. That's why we can eat or we can take the medicine safely. Okay. Second is the in the food industry. Food industry. Can you guess what the food is? Yes. It's common. We live and we eat in our daily life. No. Okay. Yes. Sugar. Betul. Sugar from sugar cane, right? So raw sugar from sugar cane basically contain the natural compound and color. Natural fiber and color compound. So we want to remove that. So we to get the pure white pure crystal. So we want to remove that. So we can see the sugar that we eat white color, right? That's why. Then the taste is so good. Okay. And lastly is in the electronic industry. This is most important because electronic in the production of semiconductor have a silicon. Silicon is it need to completely pure. Completely pure because when have some impurities in the silicon, it will affect your device to function properly. To function properly. Okay. So it use recrystallization to get pure silicon crystal. Okay. You see, this is you see that there is a basic thing. You see that as a basic experiment, but it's a bit this in our industry. Okay, that's all for us. Thank you.